Welcome back to eCoreAcademy, students. My name is Anita and I am one of the teachers and co-founders here, along with my younger brother, AJ. As you can see, today I prepared for us a new Algebra 2 lesson. In this, we're going to be continuing our quadratics unit. We are nearing the end, but there are a few subtopics we have to cover with the quadratic formula, so this is going to be part 2. If you don't remember or you haven't watched the previous video, it is the quadratic formula part 1. In that video, I just introduce you to what the quadratic formula is. I show you the actual formula itself. And because we're Algebra 2 students, because we're higher level math students, I show you how to derive the quadratic formula from the standard formula that we know, from ax squared plus bx plus c equals 0. I show you how to derive it. And then after that, we do a really simple practice problem where I just give you a quadratic equation in standard form. And instead of using factoring or completing the square, we use this third method that we learned, the quadratic formula, to solve it. And then we found the two solutions for x. In this video, we're going to be doing an application, just like I promised. An application is a word problem. So in this case, it's going to be a quadratic application. And to solve it, we are going to be doing two methods. One, we are going to be applying the quadratic formula, so solving a quadratic application using the quadratic formula. And the second part of this video will be teaching you how to use your TI calculator to solve quadratic equations. Whenever you are taking an assessment, it is highly likely that you're going to be allowed to use your TI calculator on it. So I might as well just show you how to do that as well, because obviously using a calculator is much faster than doing it by hand. But if you're not allowed access to that device, then you should just as well know how to do this by hand. That's why we're going to be working through the solution in both ways, and you're going to get the same answer. You're going to get the same correct answer, and I'm going to show you exactly how we get there. So before I even get into the video, I would really appreciate it if you like the video, subscribe to the channel, hit the post notification bell, and drop a comment down below of what you thought. Also, please use our socials in the description box below to share and spread the word about eCoreAcademy. All your efforts are very much appreciated, and all of it is reflected back onto the student community, so it benefits all the people who come here to use eCoreAcademy to up their learning game. All right, with that being said, let's get right into the video. So here's the actual problem. I'm going to give you the word problem. So your school's art class is selling paintings for a fundraiser. So try to picture this, especially when you are doing application problems. Try to actually picture the scenario and put it in terms that are easier for you to understand. So imagine your school, your high school, middle school, wherever you are, and you have an art class. You have a group of students who are part of the art class, and you're part of that art class as well. And you all are trying to find ways to make money outside of asking the school for money, and you decided to do a fundraiser. And in this fundraiser, you are raising money, but you are doing it by giving something in return to the people who are giving you the money. So these people who are giving you the money might be part of your community. And in exchange for their money and their support, you are selling them paintings. Because you're an art class, you all work on paintings. You are picking some of these paintings and you are selling it to whoever is willing to pay for them. So that is the whole theme of this word problem. The total profit Y depends on the amount X that you charge for each painting. So these are going to be your Y and X variables. So Y, I'm just going to write it up here. Y is equal to the profit, and X is equal, like your Y is equal to your total profit, and then X is equal to the amount of money you charge per painting. So per painting. And obviously, if we put it in whatever formula I'm going to be showing you next, you'll see that X, depending on the amount of money you get per painting, is going to determine how much money you actually make. So that's the relationship. So the total profit Y depends on the amount X that you charge for each painting. Y is profit. X is the amount of money in dollars that you are charging per painting. The equation Y equals a negative X squared plus 48X minus 300 models the profit of the fundraiser. So in this quadratic application, we are actually being told that this is the quadratic application. This is like the predictive model that models how much money you make for the fundraiser. So if you see in this quadratic application, we have minus x squared, and then we have 48x. So however much money we charge for the paintings, let's say we charge $5 for the paintings, you would plug it in for x, because x represents the amount of money we charge for paintings, and then we can just solve, and then we'll figure out what y, which is our total profit, is. And relatively, if you think about this, it makes sense. So you're plugging in how much you're charging, and then you're getting out how much you are going to be earning total. So the question, this is going to be the main question. What is the least amount in dollars you can charge for a painting to make a profit of $200? So what does this mean? So because it's a fundraiser, think of it this way. You are trying to make sure that your benefactors, the people who are actually paying you for your paintings, are paying the least amount of money as possible, because again, it's a fundraiser for the school. You don't want to be charging like excessive amounts of money. So you want to charge the least amount of money that is required, and you are trying to do that, but you're keeping in mind that your goal is $200. So although you're trying to charge as the least amount of money as possible, your goal is to make a profit of $200. So you want to charge not dirt cheap, but you want to charge as less as possible, but you still want to hit that threshold of $200. So keep that in mind. So you want to make a profit of $200. This is your goal. So we're going to be solving this. We're going to answer that last question I just read to you by using two different methods, like I said at the beginning of this video. The first is going to be the quadratic formula, and the second is going to be the TI calculator. So the quadratic formula, we are going to just be using this equation right up here. If you notice, it is actually in standard form. So y equals ax squared plus bx plus c. It is in standard form. So we can use this for the quadratic formula. And if you remember, quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac. Let me put my radical sign out more, okay, over 2a. So this is your quadratic formula, and the second one will be your TI calculator. And I'll show you exactly how to do both of those methods. So let's go to the next slide. Here is the solution pre-written for you. Like by now, you should probably be used to how I do this. I usually pre-write the solution for you. So if you're the kind of person who likes to copy stuff down before the teacher actually explains how to do the workout, please feel free to go ahead and copy that down. And then on the next slide, I'll be working through this problem. So I'll be writing down everything that's already on the screen right now, but I'll be explaining each step as I go. So if you want, take a second to pause the video and copy this down, and I'll give you a second so that you can just hit the pause button. Okay, hopefully that was enough time for you to hit the pause button. Let's go on to the next slide. Here we're going to be doing the solution together. So let me get my pen and let's start the problem. Okay, so we know that our total profit is going to be $200. That is the profit we're trying to reach. And so we can think of that as y equals 200. We can also think of our second equation as y equals negative x squared plus 48x minus 300. That's our second quadratic equation that we've been given, and we've been told that that represents the profit of the fundraiser. Therefore, if that represents the profit of the fundraiser and 200 is our goal profit, technically the 200 is going to be equal to negative x squared plus 48x minus 300. So our first step is to just look at this and set them equal to each other. So technically that 200 is going to be equal to negative x squared plus 48x minus, sorry, not 48x, before x, 48x minus 300. So, and again, we got that by saying 200 is going to be our profit. And remember, y represents our profit. So that way, we can just we can substitute 200 in for y. If we do that, we see that we only have one variable to solve for, which is x, which is the variable that we want to solve for. Because we know that the total profit, which is y, is 200, but we don't know what the minimum amount of money we want to charge per painting, which is x is. So we're trying to find what the minimum amount of money we want to charge is. So what do we want to do now? Well, before we can start quadratic formula, we need to have this, we need to make our quadratic equation look something like ax squared plus bx plus c is equal to 0. So we already said that this is in standard form, but it can't be equal to 200. It has to be equal to 0 so that we can plug this in to the quadratic formula. In order to do that, it's very simple. You can just subtract 200 from both sides, because 200 minus 200 on the left-hand side of the equation will give you 0. So if we subtract 200 from both sides, we get 0 equals negative x squared plus 48x. And then we get this negative 300, and then if we subtract 200, we get negative 500. So this is the quadratic equation we are going to be using and plugging into the quadratic formula. So a negative 1 is going to be our a value, 48 is going to be our b value, and negative 500 is going to be our c value. Okay, so now let's just go about this mathematically. So we've broken down the application into math that we can understand. We've broken the words into math we can understand. So now we're just going to have to apply the quadratic formula and solve for this. As I wrote on the previous slide, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac. And remember, you're going to have to memorize this, so the more practice problems you do and the more you write it out, it'll be easier for you to memorize for like formal assessments. Okay, so now let's plug in these values for a, b, and c. So x is equal to negative b. Well, b is 48, so it's going to be negative 48, plus or minus the square root of b squared. So b again is 48, so 48 squared, minus 4 times a, which is negative 1, times c, which is negative 500. Remember, pay attention to each number's sign. You don't want to neglect those signs, or you're going to get a different answer. So make sure you pay attention to those signs, and that is over 2 times a. So 2 times negative 1. Okay, so if we simplify that, I'm going to skip a few steps, but you're probably going to be able to do this on a calculator. Oftentimes with the quadratic formula, your teacher wants to know if you know how to use the quadratic formula. So I remember personally for assessments, we had to show all of our work. So like what we're doing right now, we had to show all of this work. However, we were allowed access to our calculators, especially if you're working with big numbers like 48 squared or negative 500 and things like that. So you're going to have to show your work as in how you use the quadratic formula, but for things like squaring 48, you're probably going to have access to a calculator. If not, it's totally fine. You can just do some scratch work off to the side, like over here on the screen. Like if you're in a notebook, you can do some scratch work over here. It's fine. But just for the sake of this lesson, I'll just go through this faster if I just tell you, like straight up, like what these values are. So we have that negative 48 plus or minus. I'm going to bring that down. Then we have the radical sign. So 48 squared is, I'm just going to tell you, is 2,304. So 2,304. And then if we look at this over here, negative 4 times negative 1 is just 4, and 4 times negative 500 is negative 2,000. Sorry, 2,000. So we just did negative 4ac, and we got that negative 2,000, and that's going to be over 2 times negative 1, which is just negative 2. So afterwards, we are going to get x is equal to negative 48 plus or minus. So 2,304 minus 2,000, that's pretty easy. That's just 304. So the square root of 304 over negative 2. If you simplify that, the square root of 304 is about 17.4356. I just rounded it off to the 4 decimal places. So negative 48 plus or minus 17.4356 over negative 2. So this is where we simplified everything in the radical sign. So we got this far. Okay, so what do we do now? As you can see, you probably remember what I mentioned in the last video with the quadratic formula, how you get this plus or minus. This is because when you're taking the square root of something, you can have two different solutions. You can have a positive solution, which we call the principal root, or you can have the negative solution. I'll give you an example. So square root of 25. You all usually think 5. So you're usually going to assume that the square root of 25 is 5. And yes, for the most part, on an assessment, your teacher will ask you that. You'll put 5 down as the answer. However, realistically, there are two different answers. 5 is just the positive or principal root. However, you can also have negative 5 as an answer, because if you think about it, negative 5 squared is negative 5 times negative 5, and that is equal to positive 25, because the negative sign times the negative sign pretty much cancel each other out, and you get positive. In this case, with the quadratic formula, we acknowledge both the positive and negative root. Therefore, we've written plus or minus 17.4356. Therefore, we have two possible solutions. So we need to solve for both of those solutions, and then we can answer the question, and I'll revisit how we do that and how we narrow it down to the actual answer. So the first thing we're going to do is we have to solve for negative 48. So I started off with, in my solution, negative 48 plus 17.4356. So we're going to do x is equal to negative 48 plus 17.4356 over negative 2. And then our second one I'll be showing you in just a moment, but we're just going to be doing the exact same thing but subtracting 17.4356. Okay, so then if we do that, we get x is equal to negative 48 plus 17.4356 is equal to negative 30.5644 over negative 2. And then if you just divide negative 30 point blah, 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 divided by negative 2, I'm going to round it off to 2 decimal places, because remember, x represents the amount of money per painting, and money is rounded off to 2 decimal places to represent the cents. So this will be rounded off to, if you look at here, if you look at this, the negative sign of the numerator, it cancels out the negative sign of the denominator. So negative divided by negative is a positive. So if you can just think of it as 30 divided by 2. And this is going to be equal to about $15.28. Okay, so let's do the same thing, but with doing negative 48 minus 17.4356. So if we do x is equal to negative 48 minus 17.4356 over negative 2, then we get x is equal to, well, negative 48 minus 17 point blah, 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 is equal to about negative 65.4356 over 2, negative 2, sorry. And if you divide negative 65.4356 by negative 2, you end up getting dollar sign, remember we have to include that, $32.72. $32.72. So as you can see, these are the two answers that you are going to get if you did this correctly. However, our question was asking what is the least amount of money we can charge per painting to get $200. So in this case, if we took 15.28 and 32.72, we plugged both of them in for x back into this equation we started with, they are both going to get you 200. And as you see, both of these are positive values. And remember, dollars are in positive values. So both of these are coherent answers, for lack of a better word. They both technically work. But we need to look back at what the problem was saying, because only one of these is the right answer. It was asking what is the least amount of money we can charge. Well, we have to pick which value of these two is less. Obviously, as you can see, $15.28 is pretty much half as much as $32.72. Therefore, this would be the right answer. And while this answer works, it's not what we want, because we want the least amount of money. If we can charge for $15.28, why would we charge $32.72? So that's where the logic part of this comes in. So I'm going to put an X on this, although it works mathematically, it is not correct in this context. So the answer to this would be we would have to charge $15.28 to reach our goal of $200 from the fundraiser. So that was how we solved this by hand. In the next segment of the video, I'm going to be showing you how to solve this, but with the TI calculator. So we're going to be going to the next slide where I will be showing you how to do that. Okay, so we're going to move on to the second segment of the video, and in this, we're going to be using the TI calculator to solve that exact same problem that we just solved. The whole point of this is so that you know how to use your calculator when you're permitted to, especially on assessments, to solve these quadratic applications, because this calculator is going to save you a lot more time than doing that whole using the whole quadratic formula that we just did in the first segment of the video. So I'm going to show you how to use this, and if we follow these steps together and we do this if we get the same answer that we got the last time, that means we know that we did this correctly, and we can use this method on other quadratic applications. So if you have a TI calculator near you or on you, or if you even have one, I would suggest taking the minute to go and grab it so you can follow along with this tutorial. If you don't have a TI calculator, that's totally fine. You can follow along with me as I do it up on the screen. And over on the left, you see the chalkboard. The steps will appear on there. So if you want to do this at a later time, or you want to put this down in a notebook, I would highly suggest that you just copy down the steps. And I think they're pretty easy to follow, so you won't have much trouble. Okay, so let's begin doing the solution with the TI calculator. The first thing I would suggest you do if you have your TI calculator is clear your calculators of any of the calculations you did from the last time you used it. In order to do that, you want to hit the second button, then you want to hit mem 7, second mem 712. And now your calculator is cleared. It says RAM cleared, so you're good to go. So let's start this problem. The first step is go to your y equals. So your equals key is right up here. So you're going to go to your y equals, and you see your cursor blinking in your y1. So you're good right for now. Now you want to enter y equals negative x squared plus 48x minus 500 in your y1. So our cursor is already blinking in our y1. We're not going to be typing the y in because the y is already there. So we're just going to be typing in negative x squared plus 48x minus 500. The reason we're typing this in, if you remember, our original equation for this problem that we were told at the very beginning that represented the fundraiser was negative x squared plus 48x minus 300. So what we've done is, since we already know our profit is 200, we've already gone a step ahead and subtracted 200 like we did on the last slide. So we need, even though it says y here, we need it to be equal to 0 so that we can substitute y in for 0 for this to work on the calculator. So we're going to assume we already did that. We already subtracted 200 from both sides, and instead of saying 0 is equal to negative x squared plus 48x minus 500, we just set it equal to y, so we can actually put it in the calculator. So now let's type that in. Let's put my negative, and remember to put the negative sign, not the subtraction sign. You can find the negative sign under 3 on the keypad. Don't put the subtraction sign, or you are going to get a syntax error. So put negative x squared plus 48x minus 500 in your y1. So that is set. Our next step is enter y equals 0 in your y2. So to get to your y2, you're just going to hit the down arrow. And we're entering y equals 0 in our y2 to supplement what we just did. So what do I mean by that? So we originally had 0 is equal to negative x squared plus 48x minus 500. So when we type in the calculator, we're pretty much splitting that up. So both of those sides of the equation are equal to y. So we have y equals the right-hand side of the equation, which was negative x squared plus 48x minus 500. We have y equals the left-hand side of the equation, which was y equals 0. In this case, we are trying to find the x-intercepts. The x-intercepts, if you remember, I called them solutions, roots, and quadratic equations. Those are going to be your answers. Therefore, we are going to be graphing y equals 0. Y equals 0 is a horizontal line that lies on top of the x-axis. So y equals 0 is literally the x-axis. So that's why we want to actually graph that, and I'll show you why we're graphing both of these this linear equation and then the quadratic. So I'm just going to hit 0. We have both of those set. So let's go to the next step. So then you want to go to your window and you want to adjust it. So for your x-min, you could probably just leave it at negative 10. For your x-max, you probably want to bump it up to, let's say, 50. Your y-min is also fine. Your y-max, you could probably bump that up to 100, and you should be good to go. Then you want to hit graph and give it a second. Yeah, as you can see, there's that parabola graph. And then there's actually a line in red. The glare is a little bad on my calculator, but you can hopefully see that red line that's going across the x-axis. That is our y equals 0. Okay, so now that both of those are graphed, let's go to the next step. So find the intersection. So to do that, so what does intersection mean? So we're trying to find where these two graphs touch. So as you can see, they touch right here on the x-axis and they touch right here on the x-axis. So we're trying to find exactly what those points are. We don't want to approximate, we want to know the exact point. So to do that, we're going to hit second, trace, and then we're going to come to this menu and we want to hit 5 for intersect. And now you can see that cursor right here. So as you can see, there are two different intersection points. There are two different solutions because this y=0 line passes through the parabola 2 times. Therefore, we're going to have two different solutions. So right now, because the cursor is closer to this solution on the left-hand side, it's going to find this one first. And we're going to have to repeat this intersection process to find the right-hand side solution. And we can do that by just purposefully manipulating this cursor and bringing it over closer to this. But first, let's start off with this solution. So in order to find it, we are going to hit enter 3 times. That's going to be the next step. So hit enter 3 times. It's going to ask you first curve, enter, second curve, enter, and then guess, enter. And then you will be given x is equal to about 15.28 and y is equal to 0. So hopefully the number 15.28 is familiar to you because that was actually one of the values we got from the quadratic formula. So that was our answer. That was the correct answer that we got. So we know that we did this process correctly. However, if you're doing an actual test, you're going to need to find the other solution as well. So to do that, you're just going to hit second, trace, and then intersect again. And you see how the cursor is all the way down here near the solution we just found. Well, we don't want to find that solution again. So we're going to hit the right arrow and scroll to the other side of the parabola just so that we're closer to this point over here. And then we want to hit enter 3 times. So first curve, enter, second curve, enter, and then guess, enter. And we get the second point, which is 32.717. So you can round that if you're rounding it to 2 decimal places, 32.72. That was the exact answer that we got. Those were the exact answers that we got when we did the quadratic formula. And as you see here on the steps, I said find both solutions by scrolling, which we just did. So you're going to find that you're going to look at the x. You're going to look at x. I know it's really hard to see it here, but it says 32.72 like I just said. But the two x's that you found, the two x coordinates of these 2 points, those are going to be your two solutions. So your two x intercepts. The first one, like I said, was 15.28, and the second one was 32.72. And again, since the question is asking us what is the least amount of money we can charge per portrait, we put the answer down as 15.28. So 15.28, which are dollars, $15.28, is the correct answer. So that is how you would have solved the problem. Okay, everyone, that's all I have for you today. I hope you enjoyed the video. If you did, please like the video, subscribe to our channel, hit the post notification button, and feel free to drop a comment down below. You can also share using our socials, which are Facebook, Twitter, and Instagram. You'll find them in the description box below. Also, if you have any personal or business correspondences and you want to directly contact us, please email us at eCoreAcademy@gmail.com. Also, please look at our socials as we will update you on the progress of our website, and we'll let you know as soon as that portal is up and running for all of you students to access the plethora of stuff we have available there as well. So again, that's all I have for you today. Have a great day, and I hope that video was helpful. Please look out for part 3, which is going to be our last lesson on the quadratic formula. Bye.